Today we will be discussing acceleration due to gravity. But first, I'd like to discuss about air resistance. So for very light objects like cotton or feather, it will fall slowly to the ground because of the air particles that's blocking the path of the falling cotton or feather. But if we are discussing about objects that are very heavy or very dense, air resistance is very negligible. So we will be excluding air resistance in our discussion of acceleration due to gravity. Any object, regardless of the weight, when dropped to the ground, it will have the same acceleration regardless of weight. For example, we have a 1 kg object and a 100 kg object. If you release it at the same height and release it at the same time, it will reach the ground at the same time. Now, the increase in speed will be 9.8 meters per second or 9.8 meters per second squared. In English, this is metric. In English units is 32.2 feet per second or 32.2 feet per second squared. Now, we have three equations that we use for the computation of the velocity, of the time, and the distance. Example 1. An object is dropped from the top of a building and reached the ground after 4 seconds. So the question is, how tall is the building and what is the final velocity right before it hits the ground? So for example, we have a person there and put the object at the height of the building, dropped it, and reached the ground after 4 seconds. So let us first write what are given. So what do we have? Now, when you release the object, of course the object will start, the velocity will start at 0. So your initial velocity will be 0. Now, the time that it took is for 4 seconds. So our time is 4 seconds. Now of course the acceleration due to gravity is constant regardless of the object. So it will always be the acceleration will always be 9.8 meters per second squared. Now, what do we need to find? So, find how tall is the building. So, we are computing for the distance traveled by the object. So, D is, we don't know. And what is the final velocity? So, VF, final velocity, is, we don't know yet. Now, these are the three equations that we can choose from, and so this is what we can use. So we use that one. D is equal to initial velocity times time plus 1/2 gravity, acceleration due to gravity times time squared. So we just plug in the values. D is, we don't know. Initial velocity is 0. 0 times 4 seconds. 1/2. G is 9.8 meters per second squared times time, which is 4 seconds, the quantity squared. Now this will be 0. So what we have left is 1/2 times 9.8. If you multiply 1/2 times 9.8, that is 4.9. The unit will still be the same, meters per second squared. So we have to square this. 4 times 4 is 16. Seconds times seconds is seconds squared. So the distance will be 4.9 times 16 is 78.4. Now the units, s squared and s squared will cancel out. What we have left is meters. So the height of the building is 78.4 meters. The next question is the final velocity right before it hits the ground. So we can either use this one or this one, but this one is a simpler formula, so we'll just use this one. So the final velocity is initial velocity plus the acceleration due to gravity times time. Initial velocity is 0, so automatic this is 0. Acceleration due to gravity is 9.8 meters per second squared times time. The time is 4 seconds. 4 seconds. So 9.8 times 4 is 39.2. 39.2. Now, for the units, so there's s in here, this is s squared here. So one of the s in here will cancel out with s in here. So what you have left will be meters per second. So this is your final velocity. Example 2. A stone is thrown vertically upwards with an initial velocity of 49 meters per second. How long will it take for the person who threw it to catch it? And number 2, find the height reached by the stone. So for the first question, we will just be discussing only the upward motion of the stone. So from the moment it was released by the hand until it reaches the highest position. So we will write the given. So what are given? So it has an initial velocity of 49 meters per second. So initial velocity is 49 meters per second. Now when it reaches the top, the stone will start fast and then it starts to slow down. And when it reaches the top, the velocity will be 0. So the final velocity will be 0. Now the decrease in speed or the decrease in velocity of the stone will be the same as the acceleration when it's going down or in free fall. So it will be the same, 9.8 meters per second squared, but negative. So your g, your acceleration due to gravity, will be negative 9.8 meters per second or meters per second squared. So what is being asked? Find how long. So we're looking for time. The second question, find the height. So the second question is the distance. Now from here, for the first question, they are looking for the time, so we can use this equation. So the final velocity is equal to the initial velocity plus acceleration due to gravity times time. Then we just plug in the values. So the final velocity will be 0. Initial velocity will be 49 meters per second. Acceleration due to gravity is negative 9.8 meters per second squared. There's a plus in here. Times time, which is, we don't know yet. Now, if this is negative, if we add negative 9.8 on both sides, it will be like transposing this one into the other side and making it positive. So this will become 9.8 meters per second squared times time is equal to 49 meters per second. It's now positive from negative to positive. Now we only need the time, so whatever is with time we need to remove. We need to remove this one, so we divide this by 9.8 meters per second squared. So we have to divide this one also by 9.8 meters per second squared. This will cancel out, leaving only time. 49 divided by 9.8 is 5. Now we'll analyze the unit. So meters per second divided by meters per second squared becomes meters per second times the reciprocal of this one. It will be seconds squared over meters. Meters and meters will cancel out. So one of the s in here will cancel out with this s in here. So we'll only have seconds on the final unit. So the time is 5 seconds. For the second question, find the height reached by the stone. So we will just be discussing only the upward motion from the time it was released until it reaches the highest position. So we can use either this one or this one to get the distance. So for this discussion, we'll be using this one. So D will be the initial velocity times time. Initial velocity we have is 49 meters per second multiplied by time, which is 5 seconds, 5s, plus 1/2 g. Since it's going upwards, it is negative 9.8 meters per second squared multiplied by time, the quantity squared. So time is 5 seconds, the quantity squared. Now 49 times 5 is 245. Now meters per second times seconds. So this will, s will cancel out, the seconds will cancel out, leaving us only meters. 1/2 times 9.8, it will be negative 4.9. Units will be meters per second squared. So this has to be squared. 5 times 5 is 25. Seconds times seconds is second squared. So this negative 4.9 times 25 is negative 122.5. Now s squared and s squared will cancel out, leaving only meters is equal to 245 meters. So 245 meters, or positive 245 meters plus negative 122.5 meters will be 122.5 meters. So this is your D, or this is the height reached by the stone.